Okay, so I'm going to do two examples of magic squares with doubly even order. Again, doubly even means to be an even multiple of an even integer. So for example, 4 is an even multiple of the even integer 2. And how we're going to start this is we're going to start with two boxes. I already have them written out here, but one box goes from 1 to 16 in ascending order all the way through, and the other one goes from 16 to 1 in descending order as we write them in. And then what we're going to use here is a truth table, a 4x4 matrix truth table, and for every 1 we see, we're going to take it from the position of the ascending square. For every 0, we are taking the number in that same position from the descending square. So when we go through this, if I look at that first box, I have a 1. So I'm going to go to this first box here, and I'm going to place a 1 in that position. The next two I have 0, so I go through to the descending box and put those two in the positions. I have 15, 14. And my last box in that first row is 1, so I'm going to the first square and putting 4. And I just follow this all the way through. So again, 0, 12, 2 1s here using 6 and 7, and then 0 again, so we end up with 9. Same pattern for the third row here. We have 0, so I'm taking that 8, 2 1s coming from my first box here, so I have 10 and 11, and then 0 again, left with 5. And our last row here, so we have 13, 3, 2, and the 1 comes from, again, this box in the front, or in the first run, so we have 16. If we do go through here, every single column here does actually add up to 34, or every row adds up to 34. If we calculate this out, the diagonal here is also 34, and every column does add up to 34. And as well as this diagonal in here. So we do have a magic square with a magic sum of 34 for this 4x4 magic square. So the next one we're going to do is actually one of a magic square of order 8. Again, so 8 is an even multiple of the even integer 4. So again, I kind of already preset these boxes here so that I didn't have to write them all in, but we're going to start with the first box here being going from 1 in the top left there all the way down to 64 in the bottom right, so ascending order, and then opposite for the second box here, so starting with 64 in the top left this time and going all the way down to 1 in the bottom right in descending order. And then we also have an 8x8 matrix here with the truth table. Basically, if you look at it, it is just a repeat of the 4x4 matrix, just in that pattern there 4 times. But same idea. So for every 1, we're going to take the position from the first square here in ascending order. For every 0 we see, we're going to take it from the second position there in descending order. So if we go through here, again, taking the first position in that first box there in the 1, I have 2 zeros, so 63, 62, going back to 4, 5, 59, 58, and then back to my first box at 8. Moving into the second one, so 0, I'm taking the position in this descending box here, so I have 56, 1, I'm at 10 and 11, back to 0, 53, 52, 14, 15, and 49. So I'm just going to continue to go through here until I get my last box. Alright, so again I end up with 1 in that last box, so I'm using the position in the ascending square here, so I have 64. So this would be your solution to the magic square of order 8, or one solution. If you go through and add up all the rows, they do actually add up here to 260 for each of those, if you go ahead and do that math. So every row adds up to 260. Our first diagonal here, that also adds up to 260. Every column adds up to 260. As well as our last diagonal, the diagonal in the other direction, also has a sum of 260. So here we would have a magic sum of 260. And this does also work for magic squares of order 12, again, any doubly even order.